Okay, here we go. We are going to talk about the least common multiple. This is lesson 1.6 in your Big Ideas math book. It is on page 38. This is I think the fourth time now that I'm recording this video because I am running into a world of technical issues. So kids, I get it when you have problems with your computers because that's me today. So anyway, I will also share with you, I'll just share with you lots of things here today. Okay, so on page 38, you will notice, or you should notice, there are a couple of vocabulary phrases, common multiples and least common multiples. Now, when I was doing my notes, I totally forgot to write down my vocabulary words, which is really weird because I always do that. I mean, I always write them down. I don't always forget. But after I finished all my notes, I thought, oh man, do I really have to go back and erase everything or rewrite all my notes? Nah, I am not going to do that. I wrote down my vocabulary terms on a sticky note and I'm going to tape them into my notebook. So, common multiples are multiples that are shared by two or more numbers, and then I gave an example. 8, 16, and 24 are common multiples of 4 and 8, but the least common multiple is the lowest of those numbers, and that is 8. 8 is the least common multiple. Let's go ahead and walk right through example number 1 in our textbook. I'm going to stick this right in my grab my math notebook. Okay. So, example number 1 talks about finding the least common multiple using lists of multiples. And you can see on here that they just listed those multiples right there for you. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48. We could keep going on and on, but we don't need to. Then we're going to list a couple multiples of 6, 12, 18, 24, 30, 36, and we're going to stop. So then we just go back through and circle all the multiples that they have in common. They both have 36 in common and 24 in common and 12 in common, but 12 is the lowest of those multiples, so that is your least common multiple. Okay? Let's go ahead and find the LCM of 3 and 8. I'll do that one with you. I'll kind of walk with you through it on this handy dandy whiteboard that I grabbed. I'm going to zoom out of the camera real quick. There we go. All right, so this is on your own number 1. We had to find 3 and 8. So I'm going to do a couple, multiples of 3. So we'll do 3, 6, 9, 12, 15. Let's start with our 8s. 8, 16, nope, still don't have anything in common. After 15, 16, 17, 18, 19, 20, 21. And then if I count by 8, 8, 16, 24, 21, 22, 23, 24. Oh, 24. They have that in common. Oh, look at there. So, like you saw when I was just doing that I kind of went back and forth between the two different numbers to get to my least common multiple. I did a couple multiples of 3, I did a couple multiples of 8, and then I found out which one was the least common of the two of them. You can use your calculator if you're not good at listing multiples, but because it is a whole lot easier, I'm not going to lie, it's a whole lot easier to do this when you know your multiplication facts. So go ahead and try on your own 2 and 3. Pause your video, and then when you're set, come on back and we'll check on it. Oh, look, you're set. Okay. All right. Oops. There we go. So now I have an on your own number 2. Hold that up for a second. On your own number 2. I listed all my multiples of 9, and then I listed my multiples of 12. I know that 36 is where both of them overlap. That is my least common multiple. And my least common multiple of 6 and 10 is 60. Sometimes I could just multiply those numbers together, like in this case it would work. I could multiply 6 and 10 together, get 60. I could have done that here, 3 and 8, multiply those together and get 24. But that's not always going to work, because if I multiply 9 and 12 together, I get 108, and that is definitely not the least common of the multiples. So you can't always use that trick. We're going to go ahead and move on to example 2. Example 2 is using least common multiple, finding least common multiple using prime factorization. Let me zoom in a little bit again. I got a new document camera and I'm still trying to get used to it. Ooh, I think that should work. Okay. So the first thing that you're going to do, since we're finding prime factorization, is we are going to build factor trees for both 16 and 20. Again, it does not matter what factor pairs you start off with, because as long as you do it right, you will end up with the same prime factorization. The prime factorization of 16 is 2 times 2 times 2 times 2, and of 20 is 2 times 2 times 5. So then the next direction is you circle each different factor where it appears the greatest number of times. So you see how there's 2's in both the prime factorization of 16 and 24? You want to circle your 2's where it happens the most. If they're even, like if there's 2 factors in one number and 2 factors in the other, if there's 2 factors of 2 in one number and 2 factors of 2 in the other, it doesn't matter which one you circle. You just have to use 2 2's in calculating your LCM. So like I said, there's these 4 2's and then there's 1 5. So 2 times 2 times 2 times 2 times 5 equals 80. So your LCM is 80. I'm going to go ahead and walk through one more with you. This 14, finding the LCM of 14 and 18 using prime factorization. All right. Here we go. On your own. Number 4. So 14 and 18. We're going to zoom out a little bit. Not like that. Like that. All right. Okay, so 14's prime factorization is really easy. It's just 2 times 7. Both of these are prime numbers, so I'm done. '18 has a couple of different opportunities to find factor pairs. I know that factors of 18 are 3 and 6. 3 is a prime number, 6 is composite. That can get broken down into 2 times, no, 2 times 3. Now we're all at prime factors. So I'm going to write down my prime factorization of 18. It equals 2 times 3 times 3. I have 1, 2, and it doesn't matter which one I circle. If I circle this one or this one, it doesn't matter. And then I have 2 3's, and I have 1 7. So then I rewrite those, 2 times 3 times 3 times 7. I get those written down, and I just multiply them all together. 2 times 3 is 6. 6 times 3 is 18 times 7, which equals 126. So my LCM is 126. Go ahead and try that on your own for number 5 and 6. Go ahead and try those. Oh, you're ready? Perfect. Here we go. I'm gonna zoom in just a little bit more. Okay. My least common multiple of 28 and 36 is 252. And then my LCM of 24 and 90 is 360. Let's scooch that just up a little bit higher. Hopefully you can see that better. Oh, that should be good. Okay. The other thing that I want to tell you, because your homework tonight includes a little bit of extra stuff. So if you see right here, this is our homework page. And your homework is number 1, 6 through 11, 18, 22, 24, 25. Now 22, 24, 25 kind of go along with example number 3, and we're not going to go over that in this video because I want you to just be familiar and start using your textbook as a resource. Which means when you are going through 22, 24, and 25, you see that little 3 up there? That tells you that you can go back to example number 3 and it will guide you through this. So example number 3, I can look right here. It says find the LCM of these numbers. It doesn't tell you what way you need to do it. You can do it using lists or you can do it using prime factorization. But example number 3 tells you how to do it using prime factorization. The same way that we just did it. Click each different factor where it appears the greatest number of times. You just have to look at 3 different prime factorizations to circle things and multiply them together. Okay? Please let me know if you have any questions.